Okay, the side conversations need to stop. Okay, so in our example one thing I want to point out is that the x is always the independent variable. Okay, because in this equation, so the y is always the dependent. So if we have y equals 2x, the x can change to whatever it wants. It can change freely, but the y changes with it. And so the y depends on the x. So if in our y equals 2x, if the x was 4, it would be 4 times 2, and the y changes, and it would be 8 instead of 6. Okay, Alex, stop. So the y depends on the x, which is why it's the dependent variable, because it depends on the x. Okay. So in this first example, the equation y equals 128 minus 8x gives the amount y of milk remaining in a gallon jug after you pour x cups. How much milk remains in the jug after you pour 10 cups? What is my independent variable? Kaylee? X. Okay, so what is x in this situation? X is cups. Okay, because it says after you pour x cups. So our independent variable is cups. So what's our dependent variable? Kinley? Fluid ounces, yes, or the amount. So, because it says, gives the amount y. So amount, and I'll put fluid ounces in parentheses. Yep, so this would be like baking. We're going to go over some different examples. Has anyone heard of the term constant before?
Yep. Yeah.
What's a constant?
It just always keeps going.
Okay, so it doesn't change. So 128 is the constant in this example. Because the 8x, that'll change with whatever number replaces x, but the 128 will never change. So it's the constant. So if we have y equals 128 minus 8x, and our question is how much milk remains in the jug after you pour 10 cups? What is the 10 cups? What does that represent? X or y? X. Okay, so that represents x. So I know x equals 10, y equals, I don't know. That's what we're trying to find. We are trying to find what the y equals.
Equals 128.
No.
I don't get this one.
Okay, that's because you're not paying attention.
I am paying attention. It just doesn't make sense.
Okay. So we have y equals 128 minus 8x. We need to plug our x in. So we have y equals 128 minus 8 times 10. So we're just plugging our x in. It didn't give us a y, so that's why we know we're solving for y.
How do you know that x equals 10?
Because it says on here, remaining in a gallon jug after you pour x cups. So x is the cups. Y is the amount. Okay, so we know that 10 cups is x.
Are we allowed to use calculators to solve these?
Yes, you can use calculators. You don't need one yet, so sit.
I'm gonna need one now.
You can use one once you get to your homework. Okay, you should be able to do this in your head. What is 8 times 10? 80. So we would have y equals 128 minus 80. What is 128 minus 80? 48. So we have y equals 48. So that means that when we pour 10 cups out of a jug, we will have 48 fluid ounces left. That is what this 48 means. Bless you. Yes. Okay, the equation y equals 10x plus 25 gives the amount y in dollars in your savings account after x weeks. How much is in your savings account after 8 weeks? What is our independent variable? What is the x? Mari? No. Haley? Weeks. Okay, because it says gives the amount y in dollars in your savings account after x weeks. So the independent variable is weeks. So then, Mari, what's our dependent variable? Yes, amount in dollars. Okay. So I have my equation, y equals 10x plus 25. What does the 10x represent? So we're trying to find how much will be in our savings account after 8 weeks. So what does the 10x represent? It gives the amount in dollars in your savings account after X weeks. Any ideas? Okay. So we know that weeks is X, so our X equals 8, and we still don't know our Y. So we're trying to solve for Y. So we need to plug in our 8. Plus 25. Okay. So the 8 represents how many weeks? The 10 represents how much money you're adding to your savings each week. So if you're adding $10 each week for 8 weeks, how much money will you have? 80. So that's y equals 80. So then what do you think the 25 represents? That's our constant. Kaylee? Okay, that's correct. So what does the 25 represent? Yes, but like in real life, in this savings account example, what is that 25? Vinny? Okay, where is that $25? My question is why is that 25 there? Like, how come we're not doing anything with it? We're just adding it to 80. That is, so the 25 is how much you're starting with. That's how much is already in your savings account. Okay? So we just add 25 to whatever it gives us, however many weeks. So what is our final answer? What? Yes. Y equals 105. Yep. Good. You'll find out once you get to the homework. This problem?
No, I think first one, that first one. Yeah, that one.
Okay. Okay, so that 25 represents what's already in your savings, and the 10 times X represents how much you're adding each month. Okay. So on that first one, the 128, that represents how much you started with.
Why is there graphs on the next page?
I'm sorry.
We're not going to do graphs.
We are going to do graphs with this.
My wife likes it.
It's not as hard as you think. All you're doing is plotting the points that you come up with. Okay? You don't have to connect any lines. Okay. You boys need to stop. Okay, Ripley, are you good?
Yes.
Okay. Okay, flip your page over. We have our second example. You can use tables and graphs to represent equations in two variables. The table and graph below represent the equation y equals x plus 2. So that's our equation. Y equals x plus 2. If my first ordered pair is 1, 3, what is my independent variable? 1. So then what's my dependent variable? 3. Okay, because I take my y from over here and my x from over here, and it'd be 1 and 3. What about the next one? What's my independent variable? Mari? 2. And what about the next one? Kaden, what's my dependent variable? Yes, 4. I know. Okay, Kaden, what's the independent variable on this one? Independent. What'd you say? 3. Okay, Aries, what's my last one? 5. Okay, so now I need to plot these. What goes first? Do I go over or do I go up first? Over. So we go over 1 and up 3 to plot 1, 3. For 2, 4, I go to the right 2 and up 4. The last one, I go to the right 3 and up 5. Okay. For these, you do not need to draw a line through them or anything. Yes, Cameron. So, because the government wants you to know how to do this. Okay, so it'll get more, we'll use like bigger numbers in these next couple examples, and it'll show you. It wants you to see that it's a linear equation, so that it's a straight line. Okay, and that the plots aren't going to be all over the place. So see how they're in a line? That's how all of these are going to be. But it's because as the x changes, the y changes too. So that's why. Well, because. Yes, Alex. Alex. Stop. Okay. An athlete burns 200 calories weightlifting. The athlete then works out on an elliptical trainer and burns 10 calories for every minute. Write and graph an equation in 2 variables that represents the total number of calories burned during the workout. Alex. In every minute? Yeah. I think so. Yeah. Okay. Okay. Does anyone have any ideas what our equation will be or how it will start? Kinley, tell me. Okay, so what's it going to equal? Okay, good. So, can you tell me how you got that? Just by looking at it? Okay, so I'm going to change one thing because we're going to use M and C on this example instead of X and Y. Okay, but they mean the same thing. So, this equation is C equals 200 plus 10M. Yes. So 200 is our constant because that's just there. It's not changing. Because an athlete burns 200 calories weightlifting, and then they work out on an elliptical trainer, and they burn 10 calories for every minute. Anytime you see the word every, that's an important word. That means that number is going to go with the variable. Okay? So if it wants to know 10 calories for every 2 minutes, you would multiply those. Okay? So that's why we're multiplying. If it says every, they are going together. Okay? This is the same as saying y equals 200 plus 10x. We're just changing it up because we learned in 7.1 that you want to use symbols or variables that match. So we're using M for minutes and C for calories. Okay, so it gives you what we're replacing the M with. So if we write out our equation, the C equals 200 plus 10M, and our M is 10 on this one. What's 10 times 10? 100. What's 200 plus 100? 300. So my answer for that one is 300 calories. So that means that every 10 minutes I burn 100 calories, plus I already burned the 200, so I burned 300 total calories that day if I worked out for 10 minutes on that second one. So what would my ordered pair be? Raise your hand. Yes, Alex. 10 and what? No. So what is our Y? Or what is, I know we're not using Y on this. M is our first one, so you were right with the 10. So it'd be 10, comma, and then what's our Y? Kinley? No. Haley? 300. We're using our M and we're using our C. Okay, the M is the X. That's the one that's changing. So you're going from 10 to 20 to 30. And the Y is the C because that's our total, our final answer. Nice one. I don't think so. So if I plot this, I'm going to go over to the right 10 and up 300. It's important that you guys look at your labels in the units because they're not always going up by just one. This one's going to the right 20 and it's going up by 200s. So you want to make sure you're looking at that so you don't get confused. So then I have 20 minutes. So I plug that into our equation. So we'd have C equals 200 plus 10 times 20. What is 20 times 10, Alex? 200. So I would have 200 plus 200, which is 400. So my ordered pair would change to 20, 400, and I would plot that. Go ahead and do the 30 on your own. Okay, you should have gotten 30, 500 for that one, which most of you did, it looked like.